Hello, everybody. My name is Bhavin. I would like to go ahead and discuss on the presentation. This presentation is about electric vehicle charging station management using the cloud infrastructure. We'll be talking about how we're going to leverage OCPP. It's one of the protocol used to interact between the hardware for charging stations for the electric vehicles and how they're going to interact with the IT infrastructures. So in this case, we'll be talking about the cloud infrastructure, public cloud like Microsoft Azure, Amazon Web Service, or any other public cloud. Yeah, basically, what's going on at this stage is that there's a lot of discussion going on in terms of electric vehicles, and there's a lot of demand in terms of EVs, again, in terms of environmental concerns and also in the advancement of the battery technologies. So based on that, and looking into a particular demand, there has been a lot of discussion going on in terms of how we're gonna go ahead and um, design um, the infrastructure for electric vehicles. Though no doubt there is a lot of electric vehicles, but there is a lack in the setting up of the infrastructure and basically, and also to support uh, the EV adoptions, like in terms of even though if you have an electric vehicle, it's very much very hard to get the charging station around your area, or maybe even if it's around your area, it could be really very hard to um, um, charge a vehicle if it's in a remote location. For example, like you plan a route to go around like 100 miles from your home and you identify that there's no charging station around you and where you reach particular destination, and it would be a really hard time if you're not able to identify any particular charging stations around you. So that's where the excuse me, that's where the infrastructure comes into picture, where the, the cloud infrastructure or the proposed infrastructure would be able to decide and let you know where the electric vehicle charging stations are. Um, we'll talk about it in the next slide. But on the side of the slide, you see over here there are a list of manufacturers. These are the EV manufacturers like Tesla. Big ones are Teslas and BMWs and Hyundai, and there are many more. I just pull out, excuse me, 10 um, EV manufacturers uh, over here. Going ahead on the next slide, as I mentioned earlier, in terms of the challenges of EV charging infrastructure, is basically the standardization and also the compatibility issues. Like as talked about, the multiple um, EV manufacturers who are designing the are and manufacturing the vehicles, but at the same time, we also have to understand that there should be some sort of protocol um, between all the industry and the charging station providers, um, which could allow different vehicles to charge their vehicles. And also, it has a lot of difficulty in managing and monitoring the charging stations. And in this case, I'm talking more about remotely in as in basically if you have a charging station or if you are the owner of the charging station and you have those devices at a remote location, how are you gonna go ahead and manage those charging stations as well? So there's a lot of discussion in terms of difficulty in managing and monitoring the charging stations as well. Going ahead further, in terms of introduction and also how we're going to integrate this uh, this EV with the charging station, and also what sort of protocols could be used um, so that there's a connection between the EV and the charging stations, and also from the charging stations to the cloud infrastructure. So here I'm talking about uh, Microsoft Azure or AWS or any public cloud. So it could be. I keep this point open where we can either discuss what sort of infrastructure we can utilize. It's more of like how efficient it could be. It can be Azure, it could be AWS, or it could be any public cloud. It could be Google Cloud, or it could be an IBM cloud. But at the end goal over here is to identify um, what's the best for the EV users here. Going on to the next slide. And so how do you identify the electric vehicle? So basically there would be a unique identification for each EV. Similarly that we have a battery management system for monitoring battery health and the performance. And this is all about the EV. Again, there are many more components within the EV. There could be many telematics, which we could also monitor uh, within the EV using the cloud infrastructure. But at the same time, we are focusing right now on the charging station. So more towards the charging station is basically how the physical connection is, how the EV is going to get connected to the charge point. How are the charge points available? For example, there should be a particular dashboard which should say, or a mobile app which should say that, okay, I'm here at this location. Will I able to find out how many charging stations or charge points are available at this particular location? Will I be able to reserve that particular charging points at some point, and so on? And also in terms of the interface, like it also should have a capability of uh, providing information in terms of the session control, payment, and the interaction. At the moment, what we see is that though there are really good charging stations, but there is a lack of connectivity between the cloud infrastructure and and those charging stations, and that's why it becomes really hard for the charging station provider to manage those charging stations if they have n number of sites and they have n number of charge points available onto that site. So this particular proposal could help in getting everything in one place. And again, the most important part is the network connectivity for the like to manage the communication between all the charging stations which are deployed throughout the country and could be managed with a central management system. So that would be another advantage over here. Going ahead further, so talking about the OCPP. OCPP is nothing but a open charge point protocol. It's basically a standard protocol for interoperability between the charging station and the central management system. And the key functions basically is like it allows the cloud provider, or I would say Azure or AWS or Google Cloud, to host this particular management system within the public cloud, and then you will be able to manage certain things like session management. And when I say session management, it's like you can initiate a charging, you can stop the charging, you can decide who can charge the car, and based on the subscription, you can do a remote control like start stop. I can update the firmware of the devices and so on, and not just the sessions, but also it'll be great to have a management system which allows you to do the data exchange within the uh, charge point. So, for example, if one of the charge point is having some issues, so it could flag it that the charge point is not working right now, or maybe a flag that will help the technical team to go ahead and look on site. So that sort of things can come into uh, consideration. So once again, the open charge point protocol allows you to interact between the charging station and management, and then further hosting those services within the um, uh, public cloud. Going to the next slide. Yeah. So when I was talking about the data, that could be a lot of data available uh, within the charge point management system. I have picked the most important points. So, for example, charging stations. So, what sort of data should be minimum used within the charging station? So, in my case, I have picked up like a charging station ID, the names and their location, number of ports they have, particular operator ID. So, there could be multiple operators operating on charging stations and so on. Um, Again, what sort of users who's going to be accessing the charging point, uh, talking about the charging stations, like what sort of sessions. So, for example, this would record how much energy has been drawn, who's been using it, the energy per kilowatt, the start time and end time of the process, complete transaction in terms of the payment. Uh, Again, in terms of payment, when I say like, if the user has just reached to the charging station and he can um, authorize himself, like, I'm the user for this EV and like to uh, authorize yourself, saying that, okay, go ahead and start the transaction. So it will record the start session, and based on the start session, it will start giving the charge and also make the payment when the transaction is complete. So that's all will be recorded. Again, we can also set up some sort of subscription where, for example, if a user um, or the EV user who is frequently using a particular location or maybe within a state can go for the subscription base. So then, say for example, again, the pricing is a big discussion, but considering the cost of the managing the infrastructure and then coming up with the pricing in terms of energy efficiency, there could be a subscription created. And this subscription could be, uh, say, for example, a couple of uh, dollars, which would say that, okay, for this particular subscription, you will be able to use uh, n number of charging stations throughout the state. And whenever the user go ahead and tries to connect to the charging station based on the subscription, he should be able to access the charging station at no cost because he's already um, signed up for the subscription. Further, going ahead, we can set up notifications within the database. So any transactions that were taking place will be all notified to the users. That way, it makes more seamless interaction for the users as well. That, okay, they understand the transaction was 100% and it went through. Uh, Further going ahead in terms of the fault report. So again, this would be for the administrator and the support team who works very closely with managing and monitoring uh, the infrastructure for the charging station. This would help those those admin users to understand what's the fault level. Is can there be a way where we can um, manage uh, or fix the error remotely, or do you need to go on site? So that sort of reports could be generated within the using the data. So this is a high level giving an idea about, like, if we deploy that sort of central system, it becomes more easy. So even if you are in a particular different state, some other user or an admin could log in and could report to that particular site that, okay, and somebody can on that particular site can go and visit and fix the issue for that charging station. So it gives a lot of flexibility when you have a centralized system. Um, this is how the data model looks like. This is basically the connectivity between the tables within the database. So again, this is more of, like, how the the sessions are connected to the charging stations and also with the users and so on. Going ahead further in terms of as we discussed about the database, but then how about like if you have multiple sites, so this is how it looks like, for example. So considering this is one site and this is another other site, every site is connected to the cloud over internet, and then using the charge point management system, either it could be Azure or AWS or anything hosted, having the database there. Any admin could be able to log in using using just a regular internet. Don't even need to have a setup for VPN or anything, and they would be seamlessly able to see and manage those electric vehicle charging station infrastructure. So it could be site one, site two, or n number of sites. So this is just an example which gives us more understanding about how um, how good this will be in terms of getting the um, um, uh, like easy access for admin and other users to manage the infrastructure. So it provides us with the security and compliances. As it's built in Azure or AWS, it provides scalability. So here right now we see only two sites, but it could be n number of sites, and based on how we deploy Azure and the AWS instances within Azure, it could be provide seamless integration and uh, get us going. And again, this will be real-time monitoring, so we'll be able to get the real-time analytics based on how the EVs and the charging stations are connected, and you'll get a real-time access to all the data within the infrastructure. And most important is that it will be having a secure data within the infrastructure, and that will be really helpful. So again, the integration flow basically, um, uh, in terms of just understanding the flow, is more of like how the EV electric vehicle connects uh, to the charging stations, and then how uh, the the OCPP communication authentication works. Then there's a charging station. There's the charging process management starts the charging, and then it starts the collection of the data within the Azure infrastructure, or could be any of the infrastructure. And then further, once the data is available within the infrastructure, it's pretty straightforward to analyze those data. It could be we could be using Power BI, or it could be Data Lake, or it could be any other tool within the Azure, or any cloud, public cloud, where you can manage the infrastructure. Again, in terms of the sessions, you can definitely go ahead and based on how we manage the protocols and how we manage the commands. You can set the session for termination, send a session for completion, send a session for start a transaction, and so on. Could be well maintained. Again, in terms of maintenance and update, you can do remote updates to those devices, can perform diagnostics, and also provide configuration changes. For example, I would say considering subscription, and say for example one user one is in a particular state, say Illinois, and this user is only subscribed to all the charging stations within Illinois, then he will be able to get access to all the charging stations within Illinois. Whereas the other user who does not have access to this particular subscription will not be able to access. So this configuration can quickly be changed by just going further into the charging admin portal, and then you'll be able to just update the subscription and push it to all the devices within the infrastructure. So going back onto this slide, once you update the subscription get updated to all the sites, and the user will be able to access the infrastructure and services within the infrastructure. Um, Benefits of getting of the integrated architecture. It's seamless in terms of OCPP. It ensures compatibility across multiple brands. So now we were just talking about the electric vehicles, but at the same time, there are many um, um, uh, charging point providers as well. And there are many manufacturers as well. So the OCPP could be a great point where the integration would be seamless between different brands. Scalability, I'm talking here about the infrastructure within the cloud infrastructure. So in this case, I'm talking about the Azure, which can handle, like, if there's a request for um, one site or maybe 100 site, it could be scaled up and down real quick without any issues. It also provides real-time monitoring, so that would be really helpful in terms of monitoring not just the the data which is flowing between the electric vehicles and the charging station, but also how the business is going on in terms of transaction wise. So all this could be really helpful to monetize further and generate revenue. And also in terms of operations efficiency. So basically, again, going back to the point where if there is some issues in terms of the charging stations, it really helps to a lot of remote management and taking care about the, the devices. Mhm. So basically, just to give you a conclusion again on this, the integrated architecture creates really a sophisticated and efficient EV charging ecosystem. It's really helpful for both the users, like the ones who are using the EVs, and also the ones who are managing the infrastructure. It is really helpful in terms of scalability, security, and also in terms of interoperability. And the future of EV looks really demanding. Um, so that's all I have at this stage in terms of the presentation. Thank you so much um, for looking into it, and goodbye.